Good morning, everyone. So I've gotten a couple emails about the mole project, so I want to take a minute and go over it one more time, and let you know that whatever day we return to school, hopefully that's Friday, but it might be Monday, that day we will start the day going over and grading our projects. So make sure that yours is ready whenever you return to school. We'll figure out the rest and when our tests will be and all that later. All right, so category 1 is pretty straightforward. It says, what does 1 mole of blank look like? It's supposed to be a pure substance so that you can calculate the molar mass and decide what 1 mole would be. So we used table salt as our example. So that's not one you're allowed to use in your project. But table salt is just NaCl. And we had to look up on the periodic table that sodium has a mass of 23, chlorine has a mass of 35, and together that's 58 grams per mole. And the next sentence says, also state how many particles. Since sodium chloride is an ionic compound, molecules is not appropriate. If you had picked water, that would be okay. Atoms is not really appropriate either because it contains 2 different types of elements. So the real term is formula units. In class, we just said call it particles, and you're covered, and that's fine. So you could say that 58 grams of table salt contains 6.02 times 10 to the 23rd particles of salt. Make sure you mention the correct vocabulary. All right, but that one was pretty straightforward. You can't use table salt. You could use sugar, Epsom salt, water, aspirin, maybe a household cleaner that has the chemical compound on the container. Be creative. Include a picture if you've got one. All right, so that was part 1, pretty straightforward. Part 2, dimensional analysis. This is where most people are getting stumped. It says complete one of the following sentences and then use dimensional analysis to answer the question. So we use the example of an elephant in the problem. And so the first thing you had to do was to figure out the height of your item. So we said that 1 elephant equals, I think it was like 3 meters. I don't remember. Equals 1 elephant. And then we took that and we multiplied that height by 1 mole. And so 3 times Avogadro's number gave us 1.8. That's an 8. Times 10 to the 24 meters of elephants. But then we had to figure out how tall that was. And so the example in the problem was a little bit more challenging than you probably had to do because it picked the distance from the Milky Way to Andromeda, which is like 2.5 million light years. Well, we're in meters, and the distance we measured has to be in light years. So that required a second conversion to take this meters and put it in light years. So we had to look up that conversion and then take this number and divide it to put it in light years. You could have looked up your distance in meters or kilometers because that's a little easier. Kilometers to meters is just a matter of moving the decimal. So like this one, for example, if we had just wanted to put our 1.8 times 10 to the 24 meters into kilometers, well, that would just be 1.8 times 10. Kilometers would mean moving the decimal to the left 3 spots because we're dividing by 3. So 24 minus 3 is just 21, and that would give us kilometers. But again, it's just a matter of what unit your distance is. So like from here to the moon, when we did our penny project, was in kilometers. So if we use that value, at this point, we could just divide the distance from here to the moon by this stack of elephants, and we would tell you how many times it was stacked from here to the moon. I think that's going to be easier for most of you. If you did the light years, just know that there's a second conversion. Like we went from here to here, meters to kilometers. That was a matter of dividing by 1,000 because that is 1,000 meters in 1 kilometer. But if we had to go to light years, you would have to divide by that factor to put it in the same unit. Okay, try to make it simple on yourself. Match your units. So if the height of your object is in meters, put it in kilometers, and then find a distance in kilometers. Even if it's a space distance, you can still ask Google what that distance is in kilometers, and it'll tell you. It's pretty straightforward. All right, on to the next part. Okay, part 3. A lot like the previous question, but this one was mass. So it says complete the following sentence using dimensional analysis. Okay, so here we had to look at the mass of our object. So it said that one elephant weighed, I think it was 1,700 kilograms. But then we needed a mole of those things. So we had to multiply 1,700 times a mole. I don't remember what that is right now. So you just multiply your mass times 1 mole of those things. And then you found an object that was bigger than it. And I think this example used Jupiter or something. And so then you're going to take the mass of 1 mole of, let's say, elephants. And we divided that by the mass of Jupiter. And again, making sure that your units are the same, because if our mass of my elephant is in kilograms, I'm going to need the mass of Jupiter to be in kilograms. So if you got a measurement in tons or something, just retype it in Google, what's the mass of blank in kilograms or whatever you measured your object in. Okay? And then that should give you some number. It's not necessarily a whole number, so don't let that freak you out. If you got like 1 times 10 to the negative 19, well, that's what it is. And so preferably you're going to get a positive unit, but whatever. If you multiply the smaller one by the bigger one, you're going to get a fraction. So multiply the bigger one by the smaller one to get a whole number. And so if I had to put Jupiter on top of the elephant, I'd have gotten a value of 2. But here, if I did it this way, I'm going to get 0.5. I don't like working with decimals and fractions. I mean, fractions aren't as bad, but when you're trying to do a ratio, it's not always best to do 0.5 to 1. Flip your expression here. So that instead of it being 0.5, you get a 2 to 1 ratio. Because 0.5 is a half, it's just upside down, it's the reciprocal of a half. So it becomes a little more confusing when you're looking at the values. Okay? All right, so you're just the bigger object divided by the smaller object to give you a whole number or close to it, to 1 ratio. And even if your whole number is a giant number, that's okay. Your exponent on that should be a positive value though. So you shouldn't have like 10 to the negative 19. You should have like 10 to the positive 19. So if you get negative 19 as your exponent, flip your expression. That's probably where you got that. All right. And then the last piece, pretty simple, kind of hard to do since you weren't able to get in school. So this one said to answer one of the following questions and convert the value to the mole. So the 2 questions that you were given were, how much water could you drink in a minute? Convert that to a mole. Or using chalk to write your name, how much chalk did you use to write your name in grams? We'll convert that to a mole. All sorts of things. How much air do you breathe in a minute? Convert that to a mole. Some kind of random factoid like that. Just ask Google. Google will tell you. Be creative. And then convert it to a mole using your dimensional analysis. So like if you did the water example, and I haven't looked this up, so let's pretend that Google told you that in a minute you could drink 200 grams of water. Well, then the molar mass of water is 18 grams per mole. You would take the 200 grams divided by 18. That's how many moles of water you could potentially drink in 1 minute. Let's say if it took you 25 grams of chalk to write your name, the molar mass of calcium carbonate is 100, so 25 divided by 100 is 0.25, right? Yeah. And that's how many moles it would take to write your name. So the point is to show your work and to see how all these calculations could be used for abstract things. This is a test grade. Hopefully you've shown a lot of detail. Make sure that you show all your calculations. You've included pictures, whether you had to hand draw them or print them out. But all of the work should be things that you have written down on the paper. There is a rubric. It was given to you on day one. If you forgot what it looks like, go back to the Post in Google Classroom and look at it. That's what we are going to have printed out, and that's how we're going to grade your projects when we return to school. I will assign who grades who. And then the rest of the day we'll spend on the review, what we know so far, and talk about how do we get from where we've been to our test. Your test will probably be 3 or 4 days after we return. If you have any questions, let me know. Otherwise, I will see you soon. Bye, guys.